A Nobel Prize winner once said, "When I see these equations, I feel like no human being should have seen this." What did he discover that made him feel that way? In 1957, two physicists, Chen-Ning Yang and Dao Li, did something almost unthinkable. They challenged a law so sacred, so deeply believed, that even other Nobel winners refused to question it. That law was called parity conservation. In simple terms, nature shouldn't care about left or right. Mirror the universe, and everything should work exactly the same. But Yang and Li's equations whispered something dangerous. Maybe nature does pick a side. And when the experiments came in, the mirror lied. This is the story of parity violation, the discovery that changed physics forever, and led one man to say the math itself felt holy. The sacred law of left and right. Imagine you're standing in front of a mirror. You raise your right hand. In the reflection, it looks like your left hand is raised. Simple, right? For decades, physicists believed the universe worked the same way. If you swapped left and right everywhere, like flipping the entire cosmos in a mirror, nothing should change. The rules of physics should stay identical. This idea was called parity symmetry. It wasn't just a guess. It was a foundation. A rule so trusted, questioning it was like saying gravity might turn off tomorrow. Even Wolfgang Pauli, one of the greatest physicists ever, wrote in January 1957, "I do not believe God is a weak left-hander." He was betting against Yang and Li. Confident nature would never favor one side. But here's the twist. Pauli sent that letter in the morning. By evening, he'd already lost. The experiment that broke the mirror to test Yang and Li's radical idea, scientists needed someone who could make atoms behave. That person was Chien-Shiung Wu, a brilliant experimental physicist, later called the First Lady of Physics. Wu used a radioactive isotope called cobalt-60. She cooled it to near absolute zero and aligned the atoms using a magnetic field. Then, she watched what happened when those atoms decayed. If parity were truly conserved, if the universe were perfectly mirror-symmetric, electrons should shoot out equally in all directions. No preference. No bias. But that's not what happened. The electrons didn't play fair. They preferred one direction. Over and over, more particles flew out opposite the nuclear spin. Nature had chosen a side. The mirror was broken. Parity was violated. And just like that, a law considered unbreakable wasn't. Why this matters to you, literally, now, here's where it gets personal. This isn't just about atoms and mirrors. It's about why you exist. Right after the Big Bang, the universe should have created equal amounts of matter and antimatter. But matter and antimatter annihilate on contact. If they were perfectly balanced, everything would have destroyed itself. No stars. No planets. No you. Yet here we are. That means somewhere, somehow, the balance tipped. A tiny asymmetry, maybe one extra matter particle per billion, survived. And that tiny imbalance built everything you see. This is called matter-antimatter asymmetry. And it's one of the biggest unsolved mysteries in physics. But the discovery of parity violation gave scientists their first clue. Maybe the universe isn't perfectly symmetric after all. Maybe imperfection is built into reality. And if that's true, your existence isn't an accident. It's the result of a cosmic rule that got broken. The question Yang couldn't answer. Chen-Ning Yang won the Nobel Prize in 1957. He was celebrated worldwide. But years later, In an interview with journalist Bill Moyers, he revealed something deeper. Moyers asked him, "When you look at mathematical formulas, what do you feel?" Yang paused. Then he said, "There's a feeling that no human being should ever have seen this. There's a sacredness, a power. I call it the deepest religious feeling." He wasn't talking about faith. He was talking about equations. The same math that proved parity violation made him feel like he'd glimpsed something forbidden. Moyers pressed further. "Do you see evidence of a greater intelligence behind the universe?" Yang's answer was honest. "I wish I knew. You can say it can't be an accident, that things are so beautiful and orderly. It's amazing. I don't know why." He didn't claim to prove God. He just admitted, the more we learn, the bigger the mystery becomes. The philosophical twist plus call to action. Ancient Indian philosophy asked a similar question. The eye sees. The mind understands the eye. But what is it that knows the mind? Yang spent 103 years chasing answers. He cracked one of physics' deepest laws. But that final question, the one about meaning, about design, about why the math feels sacred, he never solved it. And maybe that's the point. Because right now, you're sitting in a universe that wasn't perfectly equal. A universe that broke its own rules, so you could exist. And now, you get to decide, was that an accident? Or was there something behind it? So here's my question for you. Law? Or mind? Drop one word in the comments. Law if you think it's all random physics. Mind if you think there's something more. And if this story made you see the universe differently, hit like, subscribe, and share it with someone who loves big questions. Outro plus tease next video. Next time, we're diving into another cosmic mystery. Why does time only move forward? The answer might shock you. Until then, keep questioning. Keep wondering. And remember, the universe broke the rules, so you could be here to ask why.
If you enjoyed this video, please like, subscribe to Palsa Lab and turn on notifications so you don't miss our latest uploads. At Palsa Lab, we explore space, science, astronomy, AI, and emerging tech, bringing clear explanations and fascinating discoveries. Have a question or idea? Drop it in the comments. Stay curious, keep exploring, and thanks for watching. See you next time.